Welding plays a vital part in modern engineering, joining metals in factories and in a wide variety of work on site. It's normally safe, but there are hazards which must be taken into account to avoid accidents. Some hazards are obvious, although many aren't. Now this video is going to look at each problem area in turn. But with so many possible circumstances, we can only show a few typical examples. If you're not sure that what you're going to do is safe, you must take further advice. First, the fire hazard. Fire needs a source of ignition, a combustible material, and a source of oxygen, such as air. In welding, the welder must have air to breathe, and most welding operations provide a ready source of ignition. So we must avoid contact with combustible or flammable materials. These are often marked with a flame symbol. Most aerosols are flammable, so never spray aerosols onto hot metal. Fire precautions are simple in a workshop, but a lot of welding has to be done on site. Here we may have to take other precautions, such as preventing hot particles from reaching flammable material or equipment by shielding with metal sheets or other fireproof materials. Particular care must be taken when welding where flammable material might be hidden, behind a partition for example. Fire can break out after work has stopped, and if it's not noticed, it may spread rapidly when no one's around. Fire extinguishers should always be close to hand. Water is best for general use, carbon dioxide for electrical equipment, and foam for flammable materials. But always remember that you must have an escape route. If you're not sure that you can deal with a fire, or if there's a risk of your exit being blocked, get out. To avoid the effects of smoke, crawl along the floor. A tank or vessel full of flammable fuel, such as oil, is an obvious hazard. But just emptying it doesn't remove the danger. In fact, it makes it worse. This is because it leaves an explosive mixture of air and vapour in the tank, which can be easily ignited by any welding or cutting nearby. Heat from welding will vaporise even a minute residue of oil or tar, which has been left in a tank for years. Welding makes metal hot. The problem is it still looks the same. We expect metal on a welding bench might be hot, but work anywhere else should be marked. Arc welding uses electricity, which brings a hazard of electric shock. The electrical connections for arc welding equipment must be of proper specification and regularly checked. All cables should have good terminations, and terminals should be tight. Any damage to insulation could allow contact with live parts. As well as the welding lead to the electrode holder, we need a return lead to complete the circuit back to the welding set. An earth or ground lead of similar size should be connected to a suitable point to ensure that work doesn't become live. Except, of course, where it's already earthed, as with work on board ship. The risk of shock in manual arc welding is reduced by using the lowest open circuit voltage suitable for the electrode, or indeed by changing to direct current if available. Dry clothing will provide adequate insulation in normal situations, but the shock risk is increased if it becomes wet, or in cramped conditions where the welder might sweat or his or her body might touch metal. There must be a way to switch off or disconnect the electric supply close to the work. If the welder gets a shock, a rescuer must be able to act immediately. In tungsten arc welding, where a high-frequency supply strikes the arc, only special insulators will stand up to it. Ordinary insulating tape will break down. Next, protection for your eyes from the bright visible light from the welding arc or flame, which also emits harmful invisible infrared and ultraviolet rays. Purpose-made filters cut out these dangerous rays and allow a reasonable amount of visible light to pass through. There's a range of filter shades available. Numbers 9 to 14 are commonly used for arc welding, the higher numbers being darker. Shades 4 to 6 are best suited for gas welding. A clear sheet in front of the filter protects it from spatter and is much less expensive to replace than the filter itself. The filters are mounted in hand shields or helmets, which also protect the welder's face and neck from light, ultraviolet light, and spatter. Goggles can be used for light gas welding. When working at a bench, a welder can put his filter into position before he strikes the arc. But a helmet with an automatic filter may be better in confined places. The automatic filter allows a clear view of the work while setting up, but darkens immediately the arc is struck. Screens or curtains can be used to protect other workers nearby. Clear goggles, which are resistant to impact, are essential for grinding and chipping slag. They protect the eyes against flying particles. Now, suitable clothing's needed to protect your body. Overalls or boiler suits of a dark colour don't reflect light back under the helmet. No skin should be left exposed to direct ultraviolet rays. And clothing should be dry to give maximum protection from electric shock. If the fabric is a close weave, it won't catch fire easily. Safety boots will resist impact. And gauntlet gloves keep spatter out of your sleeves. A leather apron or cap and spats provide more protection for heavy work. Where hard hats are necessary, combination welding helmets are available. Welding produces fumes which can be harmful if breathed in. But the thing is, we can't always see them. Fumes can arise from the parent metal, the filler, or the flux. An extractor nozzle can intercept fumes before they reach the welder. The polluted air can either be vented outdoors, or the solid particles of the fume can be filtered out. An alternative larger unit is freestanding. If an extractor alone can't solve the fume problem, the welder can use a filtering face mask, which will fit under his or her helmet. This is often referred to as respiratory protective equipment, or RPE for short. This helmet has a built-in battery-powered pump, which draws air in through a filter and blows it out over the welder's face. Surface coatings such as zinc galvanizing, lead paint or plating, especially cadmium plating, will give rise to very poisonous fumes when heated. If you don't know what a coating is, then just assume that it's dangerous. Grinding off the coating near the weld will remove it as particles. Less harmful, but still needing precautions. Cleaning solvents are often flammable. Even if they're not, they should be allowed to evaporate completely before welding, as ultraviolet light from the arc may act on the vapour to form poisonous gases. Solvent containers should be kept closed when not in use. A general ventilation system will deal with any welding fumes not removed by local extractors. And from such sources as preheating, when the flames impinge on cold metal and oxides of nitrogen are formed as gases. Where welding power comes from engine-driven generators, the poisonous exhaust fumes must also be properly vented. Some welding processes use gases supplied in cylinders. They release the gas to the atmosphere. Although the gases are not actually poisonous, they cannot support life. They are suffocating or asphyxiating. They may build up in a confined space, but can be removed by a fume extractor. This must exhaust to an open space, as the gases can't be filtered out. When the gas equipment is not in use, it must be removed. Otherwise, a small leak could cause a dangerous concentration of gas to build up. Gases are supplied in cylinders at a very high pressure. They must be stored under proper conditions with ample ventilation to disperse any leaks. Make sure the correct gas is used. Don't rely on the colour codes, but check the labels. Oh, and handle those cylinders very carefully. Don't drop them or let them fall over, which could cause damage, especially to the valve and connector. For the same reason, gas cylinders must be secured while in use. The connector must be clean and undamaged. The regulator must be suitable for the gas. It must also be clean. Oh, and of course the threads must match. Finally, tighten with the correct size spanner. Gas welding and cutting uses fuel gas and oxygen, which need extra precautions to keep them safe. Acetylene cylinders must remain upright in both storage and use. Hoses should be placed so as to avoid people tripping over them or vehicles damaging them. The connectors for oxygen have normal right-hand threads, but those for fuel gas have left-hand threads to make sure they're properly connected. All equipment and fittings should be clean and dry, particularly for oxygen to avoid the risk of fire or explosion. The hoses must be undamaged and securely fastened with the proper clips. Acetylene hoses are red and oxygen hoses are blue. Liquid petroleum gas, or LPG as it's known, will dissolve ordinary rubber, so special nitrile rubber hoses, coloured orange, must be used. When first assembled, or if a leak is suspected, equipment must be tested. Use a strong solution of detergent and water. Leaking fuel gas is liable to catch fire. As a mixture of the two gases is explosive, they must be prevented from flowing back from one hose to the other if, for instance, a cylinder runs out. Hose protectors incorporate a one-way valve, which should be fitted next to the torch. The torch nozzle has a mixture of gases which normally burn at the tip. Occasionally, the flame may blow back to the inside of the torch. In this event, the torch valve should be turned off immediately. If this can't be done and the torch becomes heated, turn off the fuel gas cylinder valve, then the oxygen. This will avoid any risk of igniting gas inside a cylinder and reduce the probability of a disastrous explosion. Flashback arresters are recommended for further protection. They cut off the supply if there's a pressure surge from a blowback. If any problems arise, allow the equipment to cool, and then check it carefully before trying to resume work. When connected up, the hoses will be full of air. Setting the oxygen gas pressure, with the torch valve open, then the fuel gas, make sure that each hose is full of the right gas before lighting up. Once again, turning off gas supplies and removing equipment from confined spaces when not in use will protect against the danger from gas leaks. Oxygen won't burn by itself, but an increased concentration in air from a leak, an uncontrolled release, or even the normal operation of gas cutting equipment will increase the speed of burning, as demonstrated here. Portable grinders are often used for preparation and finishing of welded joints. Where these are electrically powered, the cable and insulation should of course be in good order, and preferably double insulated, as shown by this symbol. Note also the rated maximum speed of the grinder. The speed rating of the abrasive wheel must be the same or greater than the tool speed. The wheel must be securely fitted by a competent person. We've already looked at the need for eye and respiratory protection when grinding. Tungsten arc welding electrodes must be regularly re-ground. Occasional use of a bench grinder is acceptable, but this special purpose machine is better. Grinding of thoriated electrodes releases small quantities of harmful thorium dust. This is extracted and filtered out in a disposable bag. Mechanical handling needs the usual precautions, but welding has one special problem. If we attempt to weld on something held up by wire ropes or chains, current may flow through them, heating them and making them weak. This happens because of incorrectly connected welding return and earth leads. A properly connected welding return lead and earth lead will provide a safe route for the welding current, but it's preferable to avoid welding on suspended work. Don't exceed the rated load of manipulators, and make sure that work is securely fixed. A safe and effective welding return connection prevents currents flowing through the bearings and damaging them. With larger workpieces, look out for the risks of the work toppling over, especially where large parts are welded on. If you make a mistake, you may be trapped or injured. Ear protection is sometimes required. This can take the form of ear muffs of a type which will fit under any helmet which is to be used. This will protect the ears against noisy processes such as mechanized gas cutting, grinding, or arc air gouging. A safe means of access, with adequate rails, is essential where a welder must work at height. Toe boards protect anyone underneath against tools falling off. Radiation hazards are indicated by signs. Always take heed of these warnings and keep outside the barriers. Now, it might seem that the operators must be safe, so there's no need to worry, but they carry monitors to warn them of any excessive radiation exposure. Working in confined spaces can bring increased hazards. As many accidents happen in confined spaces, we'll look at this in more detail. Often, a permit to work system will be in use. Before starting work, a written notice is issued with details of the various precautions which have to be taken. If you don't understand any point, or if you're not sure you've got it right, then you must ask. If there's any risk, the atmosphere must be tested to ensure that it's not flammable and that it's safe to breathe. Test gas equipment for leaks to guard against poisoning the atmosphere. Or where oxygen is in use, oxygen enrichment. Fit flashback arresters to oxygas equipment. Gas cylinders should be placed outside and disconnected during work breaks in case of leaks. If the proposed welding might affect any substance, so as to form a flammable or poisonous atmosphere, expert advice must be followed to avoid danger. Check for adequate fume extraction and general ventilation. This must be sufficient to prevent any build-up of inert shielding or purging gases, and to ensure that the atmosphere remains non-explosive and safe to breathe. When manual metal arc welding, reduce the risk of electric shock by using direct current if possible. And work with the lowest practicable open circuit voltage. As we've already seen, there must be an accessible means of disconnecting the current. Follow the normal procedures for working in confined spaces. You must practice and rehearse the use of appropriate rescue equipment. Hard hats and/or extra protective clothing may be needed, and a helmet with an automatic viewing filter may be useful for work in awkward spaces. A welder's mate should be standing by to warn against fire, or to rescue a welder if he should be overcome by shock or fumes. Plan and rehearse how this will be done. More than one person may be needed to haul an unconscious worker through a hatchway. In this video, we've shown you the common hazards associated with welding and cutting, the means available to avoid danger, and planning for what may occasionally happen in spite of the precautions. We've not been able to cover every situation, but managers have a duty to enable employees to work in safety by providing a safe system of work and appropriate information and advice. In most countries, legislation spells out responsibilities in more detail and calls for records to be kept. Employees in turn have a duty to follow the systems laid down, to look after and to use the safety equipment provided, and to report anything in a dangerous condition. Together, management and employees should work towards a common goal of safe welding.